let me give you a introductory notion about normality test. So today I will explain the concept of the normality test. A normality test is used to check whether a dataset follows a normal distribution or Gaussian distribution. The purpose of normality test. The main purpose of the normality test is to verify whether the assumption of normality is satisfied for the given data or model. Next, our question is, why do we need to check normality? We need to check normality because many commonly used statistical methods assume that the data is normally distributed, like t-test, ANOVA, linear regression, etc. And violation of this assumption may lead to incorrect decisions. Then the role in choosing statistical tests. If the data is normally distributed, we can use parametric tests. And if the data is not normally distributed, we use non-parametric tests. Next, effect on statistical inference. Normality affects p-values, confidence interval, and hypothesis testing. So by checking normality, we improve the accuracy and the validity of the statistical conclusions. Next is normality in model diagnostics. In regression analysis, normality is checked for residuals rather than the raw data. This ensures valid hypothesis testing and proper model interpretation. Next, for the data transformation, when the data is not normally distributed, we take transformations such as log, square root, Box-Cox transformation. So normality test helps us to decide whether such transformations are needed or not. Next is, what are the different types of methods for testing normality? First is the Shapiro-Wilk test, which is commonly used and the most powerful for small to moderate sample sizes. Another is Kolmogorov-Smirnov test, which compares the sample distribution with a normal distribution. And another is Anderson-Darling test, which places more emphasis on the deviation in the two tails. And Anderson-Darling is mostly used when our dataset is large. I mean, for example, n greater than or equal to 30. And with the help of visualization also, like by histogram and the QQ plot, we can also check the data normality. So now, next, for testing the data normality, we will take help of the widely known software called Statistica, which is a no coding and low coding software. So with the help of Statistica, I will show you how the normality is tested. So for the normality test, I have uploaded the pistons2.sta dataset, which is an inbuilt dataset of Statistica for the self-learning purpose. So here we have 3 samples of 100 piston rings. So we will check whether these 3 samples are normally distributed or not with the help of Statistica only, Statistica's interface only, and with the help of R node and Python node. So for the first, if I check with the Statistica's node, so from Statistica, with the help of histogram, by taking the variable sample1, sample2, and in the advanced section, clicking the Shapiro-Wilk test and the Kolmogorov-Smirnov test and clicking OK. Here, in the reporting documents, we will get the histogram. And from the histogram, from the corresponding p-value, we can just check the whether the data is normal or not. The most useful test is the for the visualization is the QQ plot. So for the QQ plot also, we took the 3 samples, sample 1, sample 2 and sample 3, and the distribution is normal by default. Then in the reporting documents, if we take the QQ plot for the sample 2, so we can say that QQ plot compares the theoretical quantiles from a normal distribution in the x-axis and the observed quantiles from your data in the y-axis. So here we can conclude, since the points closely follow the reference line with only minor random deviation in the tail, we can say that data appears to be approximately normally distributed. Same explanation goes for the sample 3, that all the points are clustering around the red reference line. So we can very well say that the data is approximately normal. And in the sample 1, as compared to the sample 2 and the sample 3, few of the data points in the tail end are not on the reference line. So, but rest of all the points are clustering around the red reference line. So it is also approximately normal. So next, by the Python code.
Similarly, during the histogram also, you make the same explanation about the p-value interpretation, because
Okay,
the
sir.
whole heart of the data normality test here, first you explain the
Okay, sir.
histogram, then in order to gather the statistical evidence to the test, we take
Okay.
the p-value, right? And this is the unit of measurement, and the p-value determines.
Okay. So in the for the sample 1 in histogram, for the first sample, we can see D is equal to 0.0962. It is the statistic of Kolmogorov's KS test. Here, p-value is less than 0.05, which means that data does not follow the normal distribution. And SWW is equal to 0.9693 means this is the Shapiro-Wilk statistics, whose p-value is also less than 0.05. So we can very well say that the data is not normally distributed. For the sample 2, we can see that K statistics 0.0471, whose p-value is greater than 0.2, so which is greater than 0.05. So according to the case test, this sample 2 is normal, and according to the Shapiro-Wilk test below, SWW test statistics, p-value is also greater than 0.05. So according to the case test and the Shapiro-Wilk test, the data is normal. Again, in the sample 3 also, we can very well see for the case statistics, p-value is greater than 0.05, and for the Shapiro-Wilk test also, p-value is greater than 0.05. So we can very well conclude that our sample 2 and the sample 3 is not following the normal distribution. Next, uh, in spite of using the Statistica, using the Python node and the R node also in the Statistica's interface, we can show the data normality test. For that, we will upload the Python node and R node. For first, in the Python node, first we will write a code. The Python, I use Python 3.10.9 version. First, I uploaded pandas library for the data analysis and the manipulation purpose. And next, from the scipy.stats library, I imported the necessary library for Shapiro, KS test, Anderson, and Norm for the normality tests. So next, I first load my dataset. So here, my Pistons tools was actively uploaded in the Statistical's workspace. So any data set which is active in the Statistical's workspace can be uploaded in the Python node using this command, df is equal to active dataset. Next, I selected the necessary columns to test. First, I selected the first column, namely the sample 1. And after choosing the sample 1, I applied the Shapiro-Wilk test, then Kolmogorov-Smirnov test, and then Anderson-Darling test. So this print Shapiro-Wilk test and then this print F statistic is equal to, this will calculate the Shapiro-Wilk statistics, and this print F p-value will calculate the necessary p-value for the Shapiro-Wilk statistics. Similarly, for the sample 1, I calculated Ks test. For Ks test, first I had to calculate the mean of the sample 1, then standard deviation of the sample 1, and then for the Ks statistics, and this a p-value for the Ks statistics p-value. Next, for the Anderson-Darling test, for the sample 1, also I wrote those codes for the Anderson-Darling test. Anderson-Darling test will calculate on statistics and critical values and those with the significance levels. And according to the critical value, calculated statistics and significant level, we will interpret the result. Same code I had written for the sample 2 and the sample 3 also.
Pritha, you do one thing whenever you have been doing, just drag this interface to the besides the icon, because all the icons should be visible. So I can take
Okay,
a
sir.
print screen and yeah, keep the besides. Yeah, very good. Please now
Okay.
carry on.
Okay, so same code I had written for the sample 2, I mean for the column 2 and the column 3 for the normality checking, and just change the change minor things for column 2 for sample 2, column 3 for the sample 3, and the rest of the things remained same. Then okay, then if I run the Python node, it will produce my reporting documents in the Python node. Here we can see that for here the normality tests for the first sample. Here for the Shapiro-Wilk test, the p-value is 0. Less than 0.05. For the Kolmogorov-Smirnov test, the p-value is 0.29, which is little bit greater than 0.05. And for the Anderson-Darling test, it is not showing the p-value exactly, but what it gives, the statistics 0.7588 and the critical values and with the significance levels. So this means at 5% level, this 15, 10, 5, 2.5 are the percentage of significance level. So if we take the standard level of significance, that is the 5% level of significance, our critical value is 0.885. So here in interpretation, it is already given that if the calculated statistic greater than our critical value, we will reject the normality assumption. So here at 5% level of interest, 5% level of significance level, the calculated statistics 0.7588 is less than the critical value. So we will not reject the normality. Same assumption, same thing goes for the sample 2 also. For the Shapiro-Wilk test, for the sample 2, p-value is 0.8001. So Shapiro-Wilk test shows that sample 2 is normally distributed since p-value is greater than 0.05. If for the Kolmogorov-Smirnov test, p-value is greater than 0.05. So for the sample 2 case test also is showing that the data is normal, and for even the Anderson-Darling test also is showing that calculated statistics is 0.1719, and again in the same manner at the 5% significance level, the critical value is 0.885. So calculated statistic 0.1719 is less than 0.885. So according to the Anderson-Darling test also, sample 2 is normally distributed. Same explanation goes for the sample 3 also. By Shapiro-Wilk test, we got the p-value greater than 0.05. So Shapiro-Wilk test is also showing that data is normal. Case test also showing that data is normal because p-value is greater than 0.05. And Anderson-Darling test, it is showing that the calculated test statistic is 0.3812. So again, if we take the standard 5% significance levels at 5, so at 5% level of significance, our calculated statistics 0.3812 is less than the critical value 0.885. So according to the Anderson-Darling test also, sample 3 is normally distributed. So next, we will check the same results using R node of Statistica's interface. If we upload R, then we will write the code. So first, in the same manner as we wrote in the Python, I first uploaded the any active dataset. This is the method of uploading any active dataset in the Statistica's workspace by giving this column ads is equal to active dataset. I just renamed this active dataset as ads. Then I renamed this df1, df2 and df3 for the sample 1 and sample 2 and sample 3. So I extracted the sample 1, sample 2, sample 3 from the ads dataset, means active dataset. Next, I simply applied the Shapiro-Wilk test, Anderson-Darling test and the case test for the sample 1 and sample 2 and sample 3. So for the Shapiro-Wilk test, no library was required, but for the Anderson-Darling test, I needed to install a library called node test. So after uploading and installing the node test, I could be able to check the data normality using Anderson-Darling test by ad.test and then case test. Next, if we run the R node, we will get our reporting document in the R console. So here Shapiro.test, in the Shapiro-Wilk test also, for the sample 1, our p-value is less than 0.05. Next, for the sample 2, Shapiro-Wilk test is showing that p-value is greater than 0.05. And for the sample 3, p-value is greater than 0.05. So according to the Shapiro test, the sample 1 is not normal, as we have seen in the in our Python node also. Next, in the Anderson-Darling test also, Anderson-Darling test for the sample 1 is showing that p-value is less than 0.05. So for sample 2 also is not normally sorry, for the Anderson-Darling normality test also, sample 1 is less than 0.05. So it is not normal. But the sample 2, by the Anderson-Darling test, p-value is greater than 0.05. So sample 2 is normally distributed according to the Anderson-Darling test. And the sample 3 also, according to the edit normality test, if p-value is greater than 0.05, so it is normally distributed. For Ka statistics, showing that for the first sample, p-value is greater than 0.05. But rest of the two tests had shown us that the p-value is less than 0.05. And as we know that Shapiro-Wilk test and the Anderson-Darling test is most powerful for the normality test. So we will consider that tests results given by the Shapiro-Wilk test and the Anderson-Darling tests. Next, for the sample 2 also, K's test is showing p-value is greater than 0.05, and for the sample 3 also, p-value is greater than 0.05. So the sample 2 and the sample 3 are normally distributed. So this is the end of my today's session.
Thank you, Preeta. Thank you very much for this nice presentation.
Thank you, sir.
Yeah, thank you, Pritha.